Hi there, welcome back. This is part 2 of videos about the nth term of a geometric sequence. Make sure you see part 1 before watching this one, so go back if you haven't seen it yet. Alright, just to recap, we're going to be taking notes on the same page we were using before. And recapping where we ended the last lesson in the last video was we had just come up with the geometric sequence nth term formula, and this formula can be used to find any term in a geometric sequence. For example, if you need the 100th term, you would just input 100 here, and you can find the 100th term. Here's a geometric sequence. It is any sequence where you're going from one term to the next and multiplying by the same number. And that number is called an R value, or a ratio. It appears here in the formula, and you can see it right here. Okay, so that's the formula we came up with. Now let's look at you guys applying it. So check out this problem here. We have 4 parts. For each of them, it's a geometric progression. You need to write down the R value and then find the indicated term. So find the R value and then find the 12th term here. Okay, this is very similar to that last one we saw. We find the R value by dividing one term by the previous one. So for example, 20 divided by 40, that reduces to a half. Again, that ratio might be obvious, but sometimes it's not. So know that you can always divide like that to find it. But anyway, half times half times half, that makes sense. Then you use the formula, you're looking for 12, plug in 12, solve, solve, solve. Here's your answer. Next one, try B. Okay, in B, our common ratio can be found again, taking U2 divided by U1, the second term by the first term, or you could have done third term by second term, doesn't matter which pair you choose. Divide those, you get this value. So our value is negative 1/2. Use the formula, plug it in, ninth term is this. Okay, C. In C, again, divide one term by the previous, find out the ratio is 0.1, that makes sense. Multiply each of these by 0.1, it's becoming smaller, smaller, and then use the formula and find your U6 value. Notice that the first two questions, the answers were left in fractional form. You should, if you're relying on your calculator, for questions like that, maybe don't rely on your calculator, because we will have an exam eventually with questions that are one paper with no calculator allowed and another paper with calculator allowed. So these look like questions that would be on a no calculator test. You should be able to deal with those fractions. Whereas this one, definitely need a calculator. Okay, try D. Okay, in D, our common ratio is 2x. That's okay if we have an expression like that. There can be a variable in it. Use the formula and you end up with this. Again, it's okay that we still have the x to the 8th power. In this case, there's no way to avoid that. Okay, here's another problem. So we have, you're given the first term, you're given the 6th term in a geometric sequence. Find the values of u2, 3, 4, and 5. And such that the sequence is geometric. So anyway, we are told it's geometric, and you have to find the values in between, or the terms in between u1 and u6. So think about how you could do that. Yeah, let's see how it goes. And now let's check. So we can use the formula, our general term formula. We are given u6, so why don't we set this equal to u6? That means this n value becomes 6. We are given u1, so that u1 can be replaced by 81. We know that u6 is this value, so 1/7 over 729 replaces that. Now we have our formula with everything put into it that we know. Notice there's only one variable left, so we can solve for that. So first thing we'll do is divide by 81 here and here. If we divide a fraction by 81, that 81 basically joins the 729 in the bottom of the fraction, and then you multiply those two to get this value. Then you take the 5th root. So on your calculator there is a button that says, maybe I'll have to show you that how to do the 5th root, because I don't think it'll be an obvious button, but you can press the math button on your calculator, math, and in there you will see one of the options is a root with an x in it. You can use that one then to input any value you want there to take the 5th root. Again, press the math button. Okay, and that should give you this value here. Great, let's look at the next part of this problem. To find out all the missing values, now that you know what the R value is, it's just a matter of plugging it in, or not even plugging it in. You can say U2, you just take U1 and you multiply by the R value to get U2. And to get u3, you can just take u2 and multiply by the r value, right? So the u2 value that you found here, multiply by 1/9 to get that. Then that value which you found, multiply 1/9 to get the next one, and so on and so on. So there's a sequence written out. Okay, let's look at this one. So we have another geometric sequence, and it is, you are told you have u1 is 5 and u5 is 1280. So very similar to the last one, you know u1, you know some future term, and then you're told the last term of this sequence. So this is not the last term. The sequence keeps going after that, and eventually it ends with this value. So it looks like it might be pretty far in the future. We'll see. Given that r is positive, so the r value is positive, find the number of terms in the sequence. So your job is to figure out how far into the sequence is this final number. Is it the 10th term? Is it the 12th term? 15th? So how can you go about this? Try with the formula, see what you can get. Okay, so this time when you set up the formula, there it is. And we put u5 here because we know the u5 value. That means this becomes 5. Now you plug in the u5 value here, plug in the u1 value, which is 5 right here. This became 4. Solve for r here. Now we have r. Okay, we took the 4th root here to get rid of this. 4th root, again, use the math button to figure that out if you need to. 4. So now that you know r is 4, does that help you figure out which term in the sequence that is? Okay, let's check. So again, using the rule, we're looking for this future term. So that replaces un, and we know u1 is that. Now we know the r value. So that getting that 4 there was essential. So using this piece of information helped us get this, and now we know the r value. We can go here and go ahead and use that value, right? So we're solving here. N is our only variable. First I divided by 5 to get this. Then you can okay, this is an interesting setup here. Maybe this is not what you're thinking to do here. Later we'll do a unit on logarithms, and logarithms help us to solve when there's a variable in the exponent. However, before we learn logarithms, you should be kind of able to deal with this. And notice that this is a power of 4. And if this is a power of 4, now you have 4 to this power, 4 to this power. You can basically say, well, then that power and that power must be the same. Because if these two things are actually equal to each other, then the two exponents must be the same. So 6 equals n minus 1, and n then equals 7. This was a tricky step here, but just take a look at that process. We'll be using that in different ways as we proceed through the course. Okay, here's another one. This one's more of I guess a word problem approach here. We have the value of a car depreciates at a rate of 19% each year. That means a car's value goes down by 19% each year. If you buy a new car today for this much, how much will it be worth after 4 years? This one's a little tricky, but if you were with us last year in MYP5 math, we did ones like this, so maybe this looks familiar. Let's see if you can do this. Okay, first thing to notice is if something's depreciating 19%, you have to think of it this way. Let's say a car, this value. If a car had this value, it is worth 100% of its current, right? This is its current value, and if it retains this value, it is still worth 100% of what it was worth in the beginning, right? And then let's say this value goes down a little bit. We have to say, well, let's say the value of the car went down by 10%. Then you would say, well, what's the value of the car now? Oh, the value of the car now is 90% of what it used to be. And that's the approach we're taking here. To find the R value, we say, well, it's worth 100% in the beginning, but it depreciated or went down 19%, so now its value is 81% of what it once was. Okay, so 81% of what it was, and 81% is 0.81 as a decimal. So we can say that R value is 0.81, because basically if you take the full value and multiply it by 0.81, you will now have its new value, which is 81% of what it was, and that means it went down 19%. So plugging in 0.81 for the R value, and if it goes down to 81% every year, you can figure out after 4 years what happened. So after 4 years, you're looking for U5. You might think, well, I'm looking for U4, but no, U1 is the value right now in the beginning, and then after 1 year, that's U2. So only 1 year has passed to get U2, right? Because U1 is the value now. It's not the value after 1 year, it's now. So U2 is after 1 year, and then U3 is the value after 2 years, and so on and so on. So by 4 years, we're looking for U5 actually. Another way to think of that is when we first introduced geometric sequences, we said from U1 to U3, for example, how many jumps is that? How many R times are you multiplying by R? Well, to go from U1 to U3, you're doing one jump to U2 and a second jump to U3. And each of those jumps means you're multiplying by R. So again, to get to year 4, you have to go to get 4 jumps means 4 years. That gets you to U5. So U5 is what we're looking for. Plug everything in, solve, 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 and you get this value of the car after 4 years. That's a pretty big depreciation rate, but I think it's probably accurate. Cars depreciate very quickly. Okay, last thing you're going to look at here is a series of problems where your job is to decide whether these are geometric, arithmetic, or neither. You're now familiar with both of these geometric and arithmetic sequences, so this is a good thing to end off today, to have a summary, to make sure you understand the difference between the two. And of course, there can be many other sequences, so you can say neither also. However, if it is arithmetic or geometric, write a rule for the general term. So look at this one and decide what it is. Well, that one is arithmetic. We see it's going down by 4 every time. So here's our general term of an arithmetic sequence. That's our rule for arithmetic, right? Plug in what you know. 20 is your U1. Negative 4 is our D value. It's going down by 4. And you solve that, or no, simplify that into this rule here, a linear rule. Remember, arithmetic is linear, so we can see a linear rule here. A slope of negative 4, a y-intercept of 24. Try B. Okay, B is geometric because we're multiplying by 0.5, 0.5. We're multiplying by a half every time. So that's geometric. Here's our general geometric rule. And there's the rule here, U1, the R value in that. Okay, again, this is arithmetic. This is geometric. Those are the two key formulas we've learned so far. Next, try C. Okay, in C we have geometric again. To go from negative 4 to negative 12, we multiply by 3. Then multiply by 3 again, so our R value is 3, our U1 value is negative 4, there's our general rule. Try D. In D, it is back to arithmetic. This is negative 16, so it goes down 2, it's going minus 2 every time, so we have a D value, a common difference of negative 2 right here, and then we have our arithmetic rule starting with U1 here. You can leave it like this, of course, but it might be easier to change it to this form, the linear form. So you multiply through here, combine, and you get this. Okay, try E. Oh, well, don't try it. It's already there. It's not possible. So that one's kind of given away. But let's take a look. So it's not arithmetic or geometric. Here you're adding 1, you're adding 4, so that's not arithmetic. You're multiplying by 2, you're multiplying by 3, doesn't work. So it's not geometric, not possible. How about this one? Try F. Okay, that one I hope you notice is geometric. At first, sometimes when we see fractions, maybe you can't see what's happening, but you can see that on the bottom you're multiplying by 2, right? On the top, you can say you're multiplying by 1. So the R value can be said to be a half, right? A half times a half is 1/4. A quarter times a half is 1/8. So the multiplier, or R value, is half. And our U1 value is also a half. Hey, is this formula wrong? Yeah, that should say U1. Did that say that before? Let me check. Oh, it had it all the way along. All the way along it's been wrong. This should be UN, this should be U1. So, good thing we're going back here. Let me check one more. Yeah, same thing again. They had the wrong. They have some mistakes in this textbook, so let's be careful. That should say U1 every time. Okay, so back to here. We have our rule. Again, it should say U1 right here. Plug it in, and we have this rule. Alright, last two. Try G. In G, hopefully you can notice we have an arithmetic again. We're adding 2 every time, so there's our rule. And try H. H, we have an impossible situation in terms of arithmetic and geometric. You're adding 3, adding 4, so it's not arithmetic, or you're multiplying by 2, but then multiplying by, like, what is that, 1 and 1/6, and that doesn't work either. Okay,